today we are not going to cover the syllabus. Today we are going to cover some of the revisions, and most likely I want us to start with the revision which is part of the Form 4, that is under integration and differentiation. This is a question which mostly comes to an exam, and I'm choosing it because it is an obvious question which comes to an exam with 10 marks. Now, if we have to start with question number 1. Question number 1, we have a question reading like this one. A particle moves along a straight line such that its displacement in meters from a given point is S is the same as t cubed minus 5t squared plus 3t plus 4, where t is time in seconds. We usually know that the moment we talk about t in this displacement issues, t is representing time, and of course everything we are working here, time is in terms of what? Time is in terms of seconds. I think I've indicated it. Time is in terms of seconds. Now, we have the displacement S in differentiation. S stands for displacement, and in this case, displacement stands for distance. Displacement stands for distance. And if I have to do the analysis, because if we have to go to the question, we have question number 1. Find the displacement of the particle at t is equal to 8. And I've said t stands for time in seconds, and displacement is S, abbreviated as S. Initially it was D, but currently it is abbreviated as S. So we have to find the displacement at weight of the particle when time is equivalent to 8 seconds. Then question number P, the velocity of the particle at the t is equal to 10. Then question number C, we have the value of t, which is time, when the particle is momentarily at rest. When we talk about a particle momentarily at rest, we are going to know what do we mean by that one. Now, I want to make the summary of this displacement. When we talk about the displacement, remember we have displacement, we have integration start point. Now, when we talk about the displacement, we start with distance, which is displacement. When we talk about the differentiation, this is the differentiation, this is integration. I want us to see the difference between the two. When we talk about differentiation and when we talk about integration, this is a point topic. Integration and differentiation is a point topic. Now, the moment we talk about the differentiation, we talk about what we talk about. The moment we move from S, the moment we differentiate S, we find what we call velocity. And when we talk about displacement, we are talking about ds over dt, which is also given as what? Velocity, Then, when we talk about now velocity, if we differentiate velocity, we find acceleration. So this case it is dv out of dt, which gives us what? It just gives us acceleration. So that is the major difference. For us to move from displacement, which is distance, to velocity, then we have to differentiate ds out of dt. We have to differentiate that expression for us to come out with phi, which stands for velocity. Then, if we have the velocity, and we want to find acceleration, then we differentiate velocity in terms of dv out of dt to come up with what we call the acceleration. Now, the opposite is true, because when we talk about now integration, we start with acceleration. In this case, we start with s, we come to phi, then we come to a. But when we talk about integration, we start with a. If you integrate a, you find phi, which stands for velocity, and if you integrate phi, you find s, which stands for displacement. That is the major difference when we talk about integration and differentiation. But the equation we have here is talking about what we call the order differentiation. Now, let us move to the first part of the question, whereby they are saying a particle moves along a straight line such that its displacement in meters from a given point is s, that is distance, is the same as t cubed minus 5t squared plus 3t plus 4, whereby t stands for time in seconds. And what is our question number 1? They are saying, find the displacement of the particle at the t is equal to what? At the t is equal to 8. And now, if we are talking about the displacement, and what we are being given here, and what we are being given here is in terms of displacement. So for us to find displacement, which is abbreviated as S, we just come and substitute. Where you have t, you substitute the t you have given to be what? 8. So we have our displacement, which is S, is going to be t cubed minus 5t squared, then plus 3t plus 4, which is the same as now. Where you have t, you come and replace with your 8, because you have been told find the displacement of the particle at the t is equal to 8. Kumanisha, where you have t in your displacement equation, you come and replace with what? With 8. So we are going to have 8 cubed minus 5 into 8 squared minus 5 into 8 squared, then plus 3 into 8, then plus 4, plus 3 into 8, then plus 4. If you do the calculate, 8 cubed minus 5 into 8 squared plus 3 into 8 plus 4, we are going to have the displacement of 220 meters. 220 meters. So that is going to be our displacement when the particle is at t to be 8 seconds. Now, let us move to number P. Let us move to number P part of it. And if we have to move to number P part of it, number P, they are saying, find the velocity of the particle at t is equal to what? 10 seconds. At the t is equal to 10 seconds. Now, at this point, we cannot come and displace, or what they call replace t with directly 10, because the expression we have here, is in terms of displacement, which is the same as distance. Now, for us to find velocity from the same equation as above, you come and differentiate this expression. When you differentiate this expression, we talk about now, we have our ds over dt. We are differentiating this equation. We are going to have, when we differentiate, you know how to differentiate. This one comes here, and this one reduces by 1. So we are going to have 3t squared minus, this one comes here, 10t minus 10t plus 3. This is going to be our phi. Which is for us to say phi is the same as ds over dt, whereby if we differentiate this expression or this displacement, we are going to have our velocity or our ds over dt to be 3t squared minus 10t plus 3. But now in this case, we have been told to find this velocity when the particle is at 10 seconds, or when t is equivalent to 10. Now, since the expression we have here is already in velocity, then you come and substitute t in this expression of velocity with 10. Because already we have changed this one into velocity, or we have differentiated displacement into velocity equation. So if this is our velocity equation, and they want us to find the velocity when t is equal to 10, then what you have to do, you come and substitute the value of t with 10 in your expression of what? Velocity. So we are going to have, this is going to give us 3 into 10 squared, minus 10 into 10, then plus 3. This is going to give us 3 into 10 squared, minus 10 into 10, then plus 3. When you are having this 10 is coming from what we have given here, whereby we are finding the velocity when it is equal to 10. So after differentiating to have your velocity equation, then you come and substitute the value of t with 10. That's what we have done here, which is giving us a velocity of how much? It is giving us a velocity of 203 meters per second. We are saying meters per second because we are talking about velocity. And when we talk about the velocity, you have to give it in meters per second. You have to give it in meters per second or in kilometers per hour if you have been allowed to do that. Now, let us try to cover section C part of it. When we talk about section C, we have find the value of t when the particle is momentarily at rest. When the particle is momentarily at rest. And this is what we have been told then. When the particle is momentarily at rest, that implies our velocity is equivalent to 0, or our ds over dt is equivalent to 0. That is what we say. A particle is at rest. A particle is at rest when velocity is equivalent to 0. So for us to find t, or at the time when the particle is momentarily at rest, we come and equate our velocity equation to 0, because we have said a particle is momentarily at rest when velocity is equivalent to 0. So for us to find the time, when velocity is equal to 0, we come and equate this velocity equation to 0 to find the time when the particle is momentarily at rest. So what you have to do, you come and equate this equation for velocity to 0 for you to find t. And the 30 you find, that is the time when the particle is momentarily at rest. So you come and equate this one to 0, you come and say 3t square minus 10t plus 3 is equal to 0, plus 3 is equal to 0. Let us try to do this one here. We have 3t square minus 10t plus 3 is equal to 0, plus 3 is equal to 0. So what do we have to do? You come and factor here what is common here. You come and see this 9. You come and factor what we have here. You come and factor. Now, what we have, you can change this one. Without interfering with anything. Because we want to search for two numbers. Remember what we talked about the quadratic expressions. We want to search for two numbers. Whose sum is equivalent to negative 10. Whose sum is equivalent to negative 10, and whose product is 9. Search for two numbers. This is A, this is B, this is C. So we search for the two factors whose sum, if you add them, negative 10, which is P. If you multiply them product, 9, which is 3 times 3. So you search for two numbers whose sum, if you add them, it gives you negative 10, but if you times them, 9. What are the two numbers? The two factors are going to be what? Negative 9 and negative 1. They are going to be negative 9 and negative 1. Such that negative 9 times negative 1, you are going to find 9 positive, because remember a negative times a negative is always a positive. But negative 9 plus negative 1 is going to give you what? Negative 10. So these are the factors are going to be what? Negative 9 and negative 1. Such that if you have negative 9 plus negative 1, you get a summation of negative 10. But if you times negative 9 times negative 1, you are going to have a product of what? 9. And that is what we were aiming. Then what we have here, you come and substitute them on this part. So we are going to have 3t square minus 9t minus t, or 1t is the same, plus 3 is equal to 0. This is going to give us, we come and factor what is common here. So what is common here, we have 3t. So we have 3t into t minus 3, then minus 1 into t minus 3 is equal to 0. So we have t minus 3, and also we have t minus 3. So we are going to have 3t minus 1, what we have here and what we have here. Since this and this are the same, then factor into t minus 3 is going to give us what? Is going to give us 0. You come and do that one. We know how to do that one from quadratic expression. You come and equate the first one to 0. So we have 3t minus 1 is equal to 0. 3t minus 1 is equal to 0. If we take this one on the other side, we have 3t is going to give us 1. For us to get the value of t over 3. So our t is going to be 1 over 3. That is the first value of t. That is the first value of t. The second value of t, you come and substitute this one, or you equate what we have here on your second bracket to 0. So we have t minus 3 is equal to 0. When this one crisscrosses the equal signs, it changes the sign. So this one was a negative. The moment in another, it becomes a positive. So we are going to have our t is the same as 0 plus 3, whereby our t is going to be what? 3. So therefore, the value of t when the particle is momentarily at rest is when t is equal to 1 over 3 or 3. So these are the two possible values of t when the particle is momentarily at rest. These are the two possible values of t when the particle is momentarily at rest. So that is how we argue, or we just engage this equation the moment we talk about a question involving the differentiation and integration. Of course, maybe in our next class we will try to look on what they call the equation involving integration, so that we can compare the two. Now, I want us to move to the second part of the second equation, question number 2. I want us to move to question number 2. And in this question number 2, it is a simple question. It is a simple question and a question from section A. It's a simple question and a question from section A. And I just chose this one because it is a question which is involving what we call the area scale factor, volume scale factor, and the linear scale factor. Now, let us try to read the question. We have the question says, two similar blocks have their masses as 729 grams and 216 grams respectively. If the surface area of the smaller block is 300 square centimeter, calculate the surface area of the larger block. So these are the masses of these two different blocks. And what comes to your mind the moment we talk about masses? Masses is associated with volume. Now, we have two blocks. Let us say block A, it has a mass of 729 grams, and we have block B, which is having a mass of what? 216 grams. That is the comparison we can do. We have two blocks, whereby the first one, it has a mass of 729 grams, and we have another one which is having a mass of 216 grams. Now, what is the question? They are saying, if the surface area of the smaller block. Now, if you have to compare the two, which is the smaller block? The smaller block is the one which is having the smaller mass. And now this is the smaller block, which is having, so this one is having the surface area of 300 square centimeter. Now we want to find the surface area of the larger block. Now, the moment you are engaging in such an equation, you have to come up with what they call the volume scale factor, area scale factor, and linear scale factor. Now, if we have to find the volume scale factor from here, then we say our volume scale factor is going to be 729 out of 216. This is going to be our volume scale factor. Now, remember, there is no direct connection between the volume scale factor and area scale factor. So, we have to go to the linear scale factor. And remember what we said, volume scale factor is the same as linear scale factor cube. Therefore, linear scale factor is the same as cube root of volume scale factor. Now, having said that, now for us to find our linear scale factor, we come and find the cube root of volume scale factor. And this is our volume scale factor. So for us to find our linear scale factor, it is cube root of volume scale factor, which is 729 out of 216. 729 out of 216, which is going to give us 9 over 6, which is going to give us 9 over 6. And then this one can be simplified further to give us 3 over 2. Now, in this case, our linear scale factor is going to be what? 3 over 2. Therefore, our linear scale factor is the same as 3 over 2. Now, in this case, we are talking about calculating the surface area. For us, when we talk about the surface area, we are talking about the area scale factor. Since we have the linear scale factor, then we say area scale factor is the same as linear scale factor square. And this is our linear scale factor. Therefore, our area scale factor is going to be linear scale factor, which is 3 over 2 square, which is the same as 3 over 2 square, which is going to give us what? 9 over 4, which is going to give us 9 over 4. Therefore, our area scale factor is going to be 9 over 4. Our area scale factor is going to be 9 over 4. So for us to find the surface area of the larger block, you come and say 9 over 4 for this case. It's the same as let us say the volume of the surface area of the larger block is x over the surface area of the smaller one, which is 300. So our 9 over 4 is the same as x over 300, whereby x is representing the surface area of the larger block. So we just do cross multiply, so that we are going to have 4x is the same as 9 times 300. This gives us 4x is the same as 2700. So for us to find the value of x, divided by 4. So our x, if you do it well, is going to be 675 centimeter square or square centimeter. Therefore, the surface area of the larger block, is going to be 675 square centimeter. It's going to be 675 square centimeter. So that is how we find the area of the larger block. Now, in this question, you have to engage three things. Talk about the volume scale factor, talk about the area scale factor, and the linear scale factor. Since you are given the volume scale factor, then for us to arrange it into area scale factor, first of all, you have to convert it into linear scale factor. Then what we find as the linear scale factor, for you to find the area scale factor, you square, you find the area scale factor. So those are what the question is for today. Try to go through them on your own time. Try to do this question on your own time. Then try to see whether you find the same answer. Then try to come and do this question number 2. Then try to see whether you find the same answer. Otherwise, this marks the end of our lesson today, until we meet in the next class. Thank you.